Acceleration, right, when moving in a straight line, which means this is one dimension, right? We're only going to be going along the x-axis, x-axis only or y-axis only, right? So one dimension, right? Acceleration happens when you speed up or slow down. When your acceleration corresponds to slowing down, we call this deceleration, okay? So deceleration, well, it can get tricky depending on which way you decelerate, okay? But for now, we're not going to talk about acceleration when we change the direction of the velocity. We're only going to be talking about acceleration when we are speeding up or slowing down because we are moving in one-dimensional straight line. All right? For all problems, we will assume that speeding up or slowing down happens such that the acceleration is constant. That's kind of important because if it's not a constant acceleration, right, it's really tricky because you have to really use calculus then, right? How many of you had calculus already? Okay, so we all know the derivative of position function was the velocity function, right? And then when we take a derivative of that velocity function, we have acceleration function, right? But sometimes you can have change in acceleration. And when you take a derivative of that acceleration function, you have that is correct, which is called jerk. And that is a mathematical term. When a motion is very jerky, that means it had change in acceleration. Okay? So, in this case, we don't have any jerky motion here. We only have smooth acceleration. And that is the constant acceleration. All right? So, this constant acceleration is when you have change in velocity in given amount of time, and that is just a numerical value with no variable in it. All right? So when you take a derivative of constant acceleration, you should get a 0 as jerk. All right? So these are the constant acceleration equations that I'm going to introduce you to. All right? And you really should commit these to memory. But I will give you a little cheat sheet later when you are actually using this for your quiz or test or homework. All right? So, this first constant acceleration equation, right, is, we're going to call that equation number 1. This equation came directly from the definition of acceleration, okay? Because acceleration, by definition, is the rate of change in velocity. That's what that means. Which means it is the v final minus the v initial divided by time t. Now this time t is same as delta t if and only if t initial is equal to 0. Okay? When t initial is equal to 0, then delta t just becomes whatever the final time is. So this is where this equation comes from. Okay? Now, for some reason, they always miss this one, but I'm going to call that equation number 4, which is kind of trivial, but it's very important, right? If we have two velocities that are different, how can we find the average of those two velocities? Or, if I have two test scores, how do I find the average of those two test scores? There you go, right? Very good. So the average velocity is equal to simply the Vf plus Vi. Those, add the two and then divide by 2. That's what that means. But we also know the average velocity is also same as change in position over change in time, right? Therefore, if I set them equal to each other, right? If I set them equal to each other and solve for delta x, my delta x is equal to simply Vf plus Vi whole thing over 2 times delta t, or just t. Same thing. T or delta t, same thing. Alright? I'm going to consider that to be my equation number 4. And when I actually apply these two equations together by solving for one of the variables and substituting to the other one, we get these other two equations, and I'm going to call this equation 2, and I'm going to call this equation 3. I will talk about these equations a little bit more detail next week, okay, and show you where these equations came from. But the important thing is, all right, that all these equations right here, time t, right, or delta t, right, is always positive. You cannot have negative time. If you have negative time, either you should win a Nobel Prize in physics, or you're probably wrong. And chances are, yeah, you're probably wrong. Okay? But all other values, right, such as x initial, x final, right, delta x, right, vi, right, vf, and a must have correct pluses or minuses. Plus, we're going to consider plus as forward direction or up. Negative direction or minus direction, we're going to call that backwards or down. Okay? That's very, very important. Okay? The initial and final conditions. This is very, very important. Right? The initial and final conditions are specific to the problem you are looking at. Do not assume that the initial velocity of an object must be 0 for the problem you are solving. The initial and final values will correspond to a specific analysis window, which means you can choose anywhere to be your initial starting point and anywhere to be final point. Even though, like the whole action started here and ended here, you could consider here to be initial and right here to be the final, because you want to look at just this moment right here. Or you could just look at from here to here as your initial and final. Or you can look at here as initial and here as final. So you can choose where your initial is and you can choose where your final is, and that's where the confusion happens, because you're trying to make it convenient for yourself, but you're not sure sometimes. But it takes a lot of practice to get that done correctly. And that's where we will do, and we're going to practice more on this. All right? So wherever you're looking at, that little window analysis or analysis of window, you could choose where that window will be, and your initial position and your final position, or your initial time and your final time, can be at your convenience. All right? We'll stop there for today. Happy Friday.